All right, good evening and welcome to Master Talker online class. In today's video, we'll be talking about electric energy and power. All right. First of all, what is energy? Electric energy. Electric energy is the work done or energy released when a quantity of charge is moved between 2 points which are at different potential. Okay. You should remember the formula that said that potential difference is work done per unit charge. Don't forget that potential difference is equal to what? Work done. Work done per unit charge. All right. Potential difference V is equal to what? Work done. Work done over what? Over charge. So my work done, if I make it subject, I'm going to have VQ. Okay. So, but don't forget a formula that said that what? Charge Q is equal to IT. Yes, Q is equal to charge is equal to what? The product of current and time, because current itself is what? Charge over time. So charge is equal to QIT. Let me use capital letter Q. So if you now substitute this here, you now have that what? Work done is equal to what? VIT. VIT. All right. So that is the, or IVT. Some people call it IVT or VIT. Anyone, IVT. So anyway, which one can you remember? Anyone you can remember is okay. So now the next thing you need to know is power. What is power? Power is simply but do you remember that V is equal to IR? Yes, another one. Do you remember that V is equal to what? IR. If V is equal to IR, I'm going to have that my work done is equal to what? I squared RT. Okay? I squared RT. And that is for work done. I squared RT. So that is that. Or another way is what? Another way you can say that if V is equal to IR, then work done is what? VIR. Yes, VIR. That is another formula for work done. Anyone you like, but the one you should always remember that can give you the rest is that work done is this one. The potential difference is what? Work done per unit charge. Just know this one. With this one, any other one is not possible. Okay, and another one you can see, if you can remember VIT, this one is equally good, because most of the time they give question that is being related to this. But if you know this thing, you are good to go. You are good to go. So the next thing is your power. What is power? Power is simply work done per unit time. Work done over time is your power. So my power P is equal to what? Work done over time. And what is work done? VIT or IVT. IVT over what? Over time. So this will cancel this. So power is 4 IV. So your IV is your power. So power is IV. So that is that. Okay. So we can solve question to illustrate that. Let's solve some calculations to illustrate that. The first question said calculate. The first question said calculate the total electrical energy, okay, developed by an immersion heater with voltage supply of 240 volts, okay, when a current of 10 a.m. flows for 2 minutes. So I forgot to tell you that work done or energy is measured in joules, while the power is measured in watts. Please don't forget. Okay, so let us bring out our parameter. They gave us V is equal to what? 240 volts, and they gave you our I is equal to what? 10 ampere, and they gave you our T is 2 what? Minutes, which is what? 2 times 60, which is what? 120 seconds. Okay, so don't forget that your energy is equal to what? VIT or ITV. Anyone? IVT, IVT or ITV. Anyone? So which is what? 10 times 240 times 120. So if you multiply everything there, you'll be having 288,123 joules, which is what? 288 kilojoule. 288 kilojoule. That's the first simple question. We always start with the simple one, then we move to the more difficult ones. So this is the first simple question we're solving. The second one, the second example said, number 2 said, a heating coil is required to give 420 joules every 7 minutes when working from a 2 volt supply. Okay, then I say what length of 32 SWG Eureka wire, okay, is required to make the coil if the wire has a resistance of 8.0 ohms, 8.0 ohm per meter, 8.0 ohm per meter. Okay, so solution. What were we given? They gave us the energy, let me call the energy H. They gave me the energy as 420 joules, okay, and they gave me time. They gave me the time. Time is equal to what? 7 minutes, which is what? 7 times 60, which is what? 54 seconds. Okay, what else did they give us? 7 times 6, 36, 42. Sorry, 420 seconds. What else did they give us? They gave us volts, V as what? 2 volts. So what else did they give us? They gave us the length. Okay, they said we should calculate the length. The length L is unknown, but resistance per unit length. Resistance per unit length. Resistance per unit length is equal to what? 8 ohm. 8 ohm per meter. So if we can get the resistance, we are very, very good. So how do we get the resistance now? To get the resistance, I know that what? That my work done, which is energy. Okay, energy is equal to what? IVT. IVT. And I know that V is equal to IR. So if I put it here, I will now have that what? Energy is equal to what? I squared RT. Okay, so my energy is 420 is equal to my I. Was I giving I the current that passes through there? Is there anything like current? Okay. Okay, they didn't give us current. Okay. No current. So if there is no current, what else did they give us? They gave us volts and time. So how do we remove current here? Okay. So I know that V is equal to IR. So if I remove current, because I was not giving current, I'll have that V over what? R. So if I now put it here, I have that my H is equal to, instead of putting this, I will say V squared T over R. Because this V will times this V to have V squared, then your T over R. So you now have that what? My V is 2. So 2 squared times 420 divided by the resistance. divided by the resistance that we are looking for. You know, you have to get your resistance. Okay, sorry. Let me put everybody. I'm looking for my resistance. So I'm having that what? 420 is equal to what? My V is 2 squared times what? 420 seconds. Okay, now divided by my R I'm looking for. So my R will now be what? 4 times 420 divided by another 420. So what do I have as my R? My R will now be 4 ohms. This is my R. But I have that my R over L is equal to what? 8. So but I know my R. So my L will now be what? R divided by 8. If you cross multiply, so I'm having my R4 divided by 8, which is what? 0.5 meter. So that is my length. 0.5 meter is my length. Okay? So the next question, question number 3, said a potential difference of 6 volts is used to produce a current of 5 ampere for 200 seconds through a heating coil. Okay, then they now say calculate the heat produced. I hope you know that heat is energy. Yes, heat is energy. So we have solution. So we have that my energy, which we represent as heat. Okay, H. My energy is I have my, okay, let me bring out parameters. I have my V as what? 6 volts. I have my current as equal to what? 5 ampere, and then my time as 200 seconds. So I know that my energy is equal to what? IVT. Okay, very simple. So which is what? 6 times 5 times 200, which is what? 6 times 5, 30. 30 times 2 is 60, 00. So that is that. So that is joules, which is what? 6 kilojoule. 6 kilojoule. The next question number 4. This is very simple. Question number 4 said a lamp. Number 4, a lamp is marked 600 watts. That is the power. Okay, you say calculate the energy it would consume when connected to a 220 volt source for 1 hour. Solution. Okay, now we know that, let us bring our parameters. The power they gave me is what? 60 watts. Okay, and then what else they give me? They gave me volt as what? 200 volts. Okay, they now say what else they give me? They gave me time as what? 1 hour, which is what? 1 times 60 times 60, which is what? 3600 seconds. Okay, so I know that power is equal to what? Energy over time. Energy over time. So my energy is equal to what? Power times time, which is what? 60 times 3600. So what do you have? You have 216,000 joules, which is what? 216 kilojoule. Very simple. We don't need the vote for anything. We are not voting for anybody, so we don't need it for anything. So that is that. So the next question said calculate. Question number 6. They gave us in parallel 40 ohms, and another 40 ohms again. They are both connected in parallel. the current that the volt that and the current that entered there is 1.2 ampere. Then the same current flows out here, and I have 12 volts here. Then I say calculate the total heat energy developed in 5 minutes by the system above. Okay, so just bring out your parameters. The first thing I have is the current I. My I is 1.2 ampere. Okay, so the second thing I have is the resistor R. So to get the resistor R, they are in parallel. So I'm going to say 40 times 40 divided by 40 plus 40. So what do I have? 1600 divided by 80. So what do you have? 1600 divided by 80 will give you 20 ohms. Okay, so what else? I have my V as what? 12 volts. So they say we should calculate energy. Okay, and energy is heat energy. So don't forget that energy, V is equal to IR. So V is equal to IR. Right? So they say we should the total energy is what? H is equal to V is equal to IR. Or using this, you get the same entity. So I have that my heat energy is equal to what? V is equal, sorry, energy is what? IVT. Sorry, IVT, which is what? My I is 1.2 times my V is 12 times my time. The time they gave me is 5 minutes. That is 5 times 60. So if you do everything, you are going to get 8640 joules. 8640 joules. All right? That is that. If you decide to use your resistor, you still get the same answer. I have that H is equal to what? I squared RT, which is what? 1.2 times my R, 20 all squared times my time, 5 times 60. Are we going to get the same answer? That's the problem. Okay? Okay, the total voltage there is 24. Yes. Sorry, the total voltage there is 24 because we have the first voltage for this and the other one for this. So the total voltage there, because it's not the same voltage that is entering there. So the total voltage there is 24. So since 40 are in parallel, so across 12 voltage of the potential difference is equal at the same. Okay, so the total voltage should be 24. But voltage in parallel are the same. Voltage in parallel, yes, are the same. Potential difference across are the same. So instead of making mistake, please, let's use this formula. H is equal to I this thing squared. So which will give you that 8640 joules. So that is that for that. Right? So electrical power. We have already defined power. So let us solve some questions concerning power. The first question here said we should calculate the power dissipated by an electric heater of 220 volts at a resistance of 20 ohms. Resistance of 20 ohms. So this is very simple. Just know that power is equal to 4. Yes. Power is equal to 4 IV. Power is equal to 4 IV. So, but here I don't have my voltage. I have my voltage as 220 volts. I have my R as 20 ohms. So they didn't give me I, but I know that V is equal to IR. So to get my I is equal to V over R, which is what? my V is 220 divided by 20. So I have 11 ampere. So if you now put it here, my power is equal to what? 11 times 220. So what do you have? 11 times 220, which will give you what? 11 times 220 is, I think, 2420 watts. 11 times 220. This into this is 11. 11 times this will give you, I think, 22. Okay, 2420 watts. 2420 watts. That is 2.42 kilowatts. That is that. Don't have calculator. You people can contribute and buy calculator for me. Mine spoiled. All right. So the next question, question number 2, said calculate the amount of work done when a current of 15 ampere is passed for 30 seconds through a potential difference of 2 volts. Solution. What do we know? We know that heat energy is equal to what? IVT. So which is what? My I is 15 times my V is 2 times my 30. So if you do that, you have 900 joules. 900 joules. Okay? This is very simple. So that is that for that. Okay? Let me check my time. Okay, let's solve this question. They gave us this one like this. As 6 ohms. And this one like this as 3 ohms. These two met here. And I have something like this. 12 volts. So what they say we should do? They say in the diagram, come above, what is the ratio of the electric power dissipated in the 6 ohm resistor to that in the 3 ohm resistor. Okay? All right. So you should know that I don't know. Okay? You should know that power is the same. Power is equal to what? Power is equal to 4 IV. All right? But I don't want to use V. I want to use R. So, but I know that V is equal to IR. So, therefore, V is equal to what? V is equal to IR. So, if I put it here, I have the what? I squared R. Okay? I squared R. But I don't have current. Since I don't have current, so let me make I subject. If I make I subject, I'll have that V over R. So, therefore, I have what? V squared over R. So V squared over R is my is the formula for my power. That's the formula for power. Okay. So what does it mean? This thing means that what? That if I make V square subject, V square, it means that what? That power is inversely proportional to resistance. So if I make V square subject, I have what? PR. So let me call it P1 R1 is equal to what? P2 R2. Okay. So now the P1 over P2 is equal to what? R2 over R1. Okay. So we now have the ratio that is P1 over P2 will now be what? This is, let me call this R1 and R2. So it will now be 3 over 6. So P1 is to P2 is equal to 1 is to 3. So P1 is to P2 is 1 is to 3. 3 divided here is 1. 3 divided here. So 1 is to 2. Sorry. 1 is to 2. Okay. Any other question? So the next question here, the next questions gave us you have learned another formula that P1 R1 is equal to P2 R2. So this is 10 ohms and this is 5 ohms. And then current entered this way. This is my I current. Okay, and then flows outside here. Okay, then I say in the figure, in the figure above, comma, current I passes through a parallel. Current I passes through a parallel combination. Then I say if the power dissipated in the 5 ohm resistor is 40 watts. Calculate the power in the 10 ohm resistor. Okay, so we will tell them that what? That P1 R1 is equal to P2 R2. So what do we have now? So we are looking for the power. So the P2 now will now be what? P1 R1 all over R2. So what do we have? My P1 is 40 times R1 5 divided by R2, which is 10. This into this I have 4 times 5, 20 watts. 20 watts. Okay? 20 watts. As simple as that. All right. Why do we use that? It's because don't forget that the potential difference across them are the same. So that is why we use that formula. So that formula is used for only parallel resistors. The resistors must be in parallel before you can use that formula, please. The resistors must be in parallel before you can use that formula. So another question, and I think which is the last question I'm going to solve for power. So we have another one that comes this way. This one is in series, 4 ohms, and then connected to another one in parallel, 4 ohms again, and 4 ohms again. 12 volts. They say calculate the power in the cell. So we want to calculate the power. Calculate the power. Calculate the total power drawn from the cell in the circuit. Calculate the power in the circuit above. Okay, so first of all we need the total resistance. So for rp, those in parallel, it will be 4 times 4 divided by 4 plus 4. So 4 times 4 is 16, 4 plus 4 is 8, so I have what? 2 ohms. So then the total resistance, this one now is now in series, so it will now be 4 plus 2, which is what? 6 ohms. So I know that my power is equal to 4 IV. So but what is my V? V is equal to IR. So which is what? I squared R. Which is there any I? Okay, there is no I. So since there is no I, I'm going to make I subject. So my I will now be what? V over R. So I have that my power is equal to 4. So which is what? My power is now V squared over R. So what do you have? My V squared is 12 squared divided by what? Divided by what? By 6. So which is what? 144 by 6. So what do you have? 144 divided by 6. So okay, so get the answer. 144 divided by 6. Okay, I have calculator now. 144 divided by 6. 144 divided by 6. 24. So I have 24 watts. Okay, so thank you very much for watching. In our next video, we will now talk about electrical energy consumption. Electrical energy consumption. What's my time? 32. Okay, or let us just do that. Electrical energy consumption. Yeah, electrical energy consumption. Let's know that everything about energy is gone.